Hi, today I'm going to walk you through making these placards or ornaments for both 3D printing and laser cutting using the Tinkercad software. My students will personalize them and secure them to their toolboxes for fun and for quick identification throughout the year. I really love Tinkercad and use it a lot in my robotics and physics classes. And while I spend most of my time in this software designing circuits and Arduino projects with my students, Tinkercad does have a simple-to-use 3D CAD design feature as well. While there are other more powerful 3D modeling programs out there, the 3D design features in Tinkercad are so simple and easy to learn that it is a good starting point for many students. Sometimes easier is better than powerful, especially when having a basic prototype in hand is more important than taking the time to learn how to use a more complex CAD program such as Onshape, SketchUp, or SolidWorks. I do have other videos demonstrating how to use the more powerful tools of Onshape and SketchUp to make similar decals and ornaments, and links to those can be found at the top of your screen, in the description below, and at the end of this video. Before jumping into how to use Tinkercad, let's take a closer look at exactly what we want to make. For most engineering tasks, you will have a very clear set of design parameters and tolerances. But our artistic ornament allows us more flexibility to be creative here. Nevertheless, it is prudent to have some idea of the dimensions of your design before starting out. If you are not working from a schematic diagram, then using common household items such as this lid can help you determine a good starting point size. This lid measures about 66 millimeters in diameter, so we can use it as a general guide for the size of our heart ornament. And for the 3D printed piece, let's make it 2 millimeters thick with text that protrudes 1 millimeter above the heart's top surface. Furthermore, let's add a hole that is just the right size for a small screw. In our robotics lab, we often use size 4 screws for our robots. So let's make the hole for this type of screw. Specifically, we use 440 screws. The number 4 tells us something about the diameter of the shaft. A number 4 screw, for example, is larger than a 3 and smaller than a 5. And the number 40 tells us that there are 40 threads per inch. We could use a caliper to measure the width of the hole needed, or we could simply look up the hole's diameter in a table like this one here. This table is meant for machinists who are using drills for cutting, but we can make use of it for 3D printing and laser cutting too. Because we want the 440 screw to fit easily into the hole, we'll make it a normal fit, which we can see from the table is 3.45 millimeters. However, because the hot plastic extruded from the 3D printer comes out a little thick, I'll make the hole just a bit larger than the table suggests. From trial and error experience, I know to make the hole 3.66 millimeters. We are now ready to begin to design our ornament. Okay, so let's get going. The first thing you want to do is you want to create a Tinkercad account if you haven't done so. It's free for educators and for students, so hop on there and create your account. And then when you get to your home page, you'll see a link here for 3D designs or circuits or whatever, and you're going to click on 3D designs and create a new design here. It's going to be named something silly like this. We're going to change that name. I'm going to call mine 3D Heart version 2. Okay, and it automatically saves, which is nice, and it saves to the cloud, which is nice, but if you don't have the internet, then you are out of luck. So, pros and cons, right? So the first thing we want to do is realize that this is our work plane, and we can build anything we want on here. And because we're building a heart, I'm in basic shapes, and I'm scrolling down to the heart, and I'm just going to drag it onto the work plane there. Okay, I can reorient my view by turning this little cube. I can also right mouse click and move around like so. And here's a nifty trick. There is no hand tool. So for example, if I move this heart down here and I want to zoom in on it, if I zoom, no matter where I put my mouse, it doesn't have a focused zoom. So it's kind of difficult to get down to there. But I've discovered that if you use a mouse, and I highly recommend when you use CAD designing that you are using a mouse, if you click on the scroll wheel, you can click and hold it and use it as a hand tool and move it around like so. Okay. So this little piece of advice there. And to move it around, I'm just left clicking on the heart and moving it wherever I want. So I can view it from the top. Again, center mouse click to hand it over. And it's kind of hard to tell how big this heart is, but if you click on it and click on one of these corners, it will tell you that in this case it's 26 by 28, and we're nowhere in millimeters because down here it tells us that that's the grid is in units of millimeters. So if you recall, we made measurements of 66 millimeters by, say, 66. Okay. And we also remember, perhaps, that we wanted this to be 2 millimeters tall. Okay. And because it's a heart, let's go ahead and change that color. Although with 3D printing and laser cutting, the color is completely unnecessary, but you know, we are artists, aren't we? All right, so there's the basic heart. And what we want to do now is place a hole in that heart. And as you might imagine, that hole can be done with a cylinder. So let's place a cylinder on our workspace. Now, that's a pretty sizable hole, and we can click here and see that it's 20 millimeters by 20 millimeters. So that's 2 centimeters. It's almost an inch wide, and of course that will be way too big for our 440 screw. So let's shrink it down a bit. If you remember, it was 3.66 for a 440 through hole, clear, and what's called a free fit, 3.66. Boom, like that. Okay. And you know, I'm going to undo that, and I'm going to show you really what a cylinder is. Okay, a cylinder. You know, in math class, you learned that it's a circle, right? That's lifted, and this is really a polygon. So in CAD software, all of your shapes are really polygons. In this case, it's a 20-sided polygon, and it mimics that of a circle. If you want it to be more circular, you could just increase the number of sides of the polygon. Okay, we can go all the way up to 64, for example, and that's a pretty smooth surface. You have to kind of zoom way in to see that it's not a circle. And for something as small as 3.66 millimeters, it's really not going to make a difference how many sides our cylinder is. Okay, but one thing we definitely want to do is we want to make this solid cylinder here not be solid, but rather be a hole. So if we make it a hole, then of course it will go through our solid pieces. Okay, and if we scroll under, you can see that the hole doesn't go all the way through. So let's just grab this little black raindrop thing and drag it down to make sure that our hole actually goes through the top and the bottom. Okay, we can click on the top guy there, just take a look at it, and then we can eyeball it if we want to. We could just move this thing around. Oh, what am I doing there? I think I'm stretching it. I'm doing something weird. So kind of have to move it around. There we go. Grab the base of it. And we can move it around and kind of eyeball, if we want to, where we want that to be. We certainly don't want it to be too close to the edge, because then that hole will interfere with the side of our heart. But, you know, it's okay if you can't get it exactly in the center. Let me show you a little trick. So I got it just at the right distance away from my little apex there. And let me just put it over here just to demonstrate what I'm about, what I want to show you. So there's the hole that's obviously not centered. If I highlight the heart and the hole, I can then click on this guy here, the Align tool, and that gives me some little black dots. And if I click on this dot, it will align the center of the hole along this axis of the heart. So, boop, just like that. Okay, so now we know that that hole is centered, and if we were to hang it, the heart won't hang lopsidedly. All right, and if we wanted to make the hole an actual hole, we would need to highlight both of these pieces and then group it together. And when you group it, then it becomes, oh my goodness, what happened? I must have lifted that hole when I was messing around with it. I surely did. Look at that. It doesn't go all the way through anymore. So I'm going to grab the raindrop, drop it down again. Okay, there we go. Highlight both, and I'm going to, I'm going to group them. And now, now there's a hole all the way through the center. Yay. So I'm going to ungroup them, and I'm going to keep working now, and I'm going to add text to the top of the heart. So there's no text tool here. Well, there is right there actually, or you can come here and go to text and numbers. And here, if you click on the text tool, click on it there, and then change the word to love, for example. Notice that there are not a lot of fonts here. There are only 4, in fact. We're pretty limited here. Again, Tinkercad is a fine tool, but it's not a very, very powerful one. So I'm going to maybe change that up a little bit, change the color just so we can tell the difference. And now let's go place it on the heart. And I want to show you this. Notice that the bottom of the word love, the bottom of the word love is actually at the bottom of the heart. And that's not what we really want. We could click on the word love. We could lift it up a couple of millimeters. But when you do things by hand, you're not always 100% that it's going to actually be on the right surface. So what I'm going to do is I'm going to delete this, and let's start over. The work plane is at the bottom of the heart right there. See that work plane there, that blue work plane? I'm going to choose the work plane tool or press W. The hotkey for work plane tool is W, and then I'm going to click on the top of the heart, and now the work plane is now at the top of the heart, so that when I go and I add my text, okay, now the text is going to be aligned with the top of the heart. So I can go back in there and edit it. Okay, and I can manually move it over. All right, and we could, obviously this is too big to fit on there, so I know kind of from experience doing it before that 50 is a pretty good dimension, and the length, and 15, and the height is pretty good. Let's see if that fits better. That looks okay. Of course, we can make it whatever size we want and move it wherever we would like there. We could even rotate it if you wanted to. Okay. And finally, we need this to be 1 millimeter instead of 10 millimeters tall. Let's align all 3 of these with the center. And now we know that the word, the heart, and the hole are all aligned with the center of the heart. Okay? And then finally, we group it. Notice we've lost our color there, which is fine. In 3D printing, the colors don't translate to the 3D printer. And then finally, all we have to do is export it. So let's highlight what we want, and then export to the 3D printer is either an OBJ, STL, or GLB file. My students will use STL, so you do that, it downloads instantly, and then you can go open up that file and then put it into your 3D printer. So that is all you need to do for 3D printing. Let's do the same thing now for the laser cutter. Before we jump into the laser cutting design, what I meant to do was to mention that a 1 millimeter height here in the word love and a low resolution printer, that's about 3 layers of plastic. So if you wanted more, you could increase that embossing height there. All right, so now let's make the same thing, but let's make it for a laser cutter. So I'm going to just copy this thing here with Command C or Control C, and I'm going to paste it with Command or Control V. Okay. And so I'm going to leave this one alone, and this is the one I'm going to play with, the pasted one from my laser cutter. So this is going to be pretty much the same thing. I'm going to ungroup it there. And the only difference here is that the word love is no longer going to be solid, but rather it's going to be a hole. Okay. And I want the height to be, let's make it 20. Okay. And then I'm going to push that down into the heart so that it's on the top and the bottom, just like we did with the hole. Now if I highlight all three and I group them, so now we can cut that out. Again, the text feature is pretty limited. There was no stencil text, if you noticed. So the letter O, when it gets cut out, that center piece of the O is going to fall away. And it's just going to be this big open hole there. If you wanted something more powerful, then you will need to use, or if you wanted a stencil font rather, you would need to use something more powerful like Onshape or SketchUp or something like that. Some other kind of CAD. But for most purposes, beginners will probably like Tinkercad just fine. So, which is why I wanted to introduce it to my students today. All right, finally, to export this, you highlight it, you go to export. This time I'm only going to choose the selected shape, and for laser cutting, it's an SVG file. You click that, grab it, and you throw it into your laser cutter like normal. All right, well, I hope this has been informative. And again, if you want to see more powerful ways of doing this using Onshape and SketchUp, the videos are listed here and also in the description, and feel free to make use of those. All right, have a great day, and thanks for joining us.